Welcome back to Geometry, Measurement, and Probability. In this video, we pick up in section 13.4 with the surface area of a right regular pyramid. So let's get started. The formula for the surface area of a right regular pyramid is as follows: 1/2 PL plus capital B. L represents our slant height, and B represents the area of the base. P represents the perimeter of the base. Now let's think about L. When we talk about slant height, the slant height goes down the side of the pyramid. The height goes from the vertex perpendicular to the base of the pyramid. But the slant height goes down the side of the pyramid and is perpendicular to one of the sides of the base. So let's find the surface area of our pyramid. Our formula is 1/2 PL plus B. So here, to find our perimeter, we have a square. So I add all four sides of that square. 4 centimeters plus 4 centimeters plus 4 centimeters plus 4 centimeters. And notice our slant height in this example is 5 centimeters. Plus the area of the base. The base is a rectangle. To find the area of a rectangle, we multiply length times width. So that would be 4 centimeters times 4 centimeters. 4 plus 4 plus 4 plus 4 is 16, or 16 centimeters. 2 goes into 16 8 times, and 8 times 5 is 40, and then centimeters times centimeters gives us square centimeters. 4 times 4 is 16, and we have square centimeters. Add these together because these are like terms, and that gives us 56 square centimeters. Now look at part B. Part B is a little bit different because here we're given the height because it comes down to the center of that pyramid rather than the slant height that goes down the side of the pyramid. So first, I need to find the slant height. I can make a triangle out of the height and the slant height. Now, the purple dotted line is going to be 2, or 2 feet. The height comes down to the middle of that pyramid, so halfway would be 2 feet. Use Pythagorean theorem, a squared plus b squared equals c squared. And if you need to, draw your triangle out to the side. Plug in 3 for a and 2 for b. 3 squared is 9, 2 squared is 4, and 9 plus 4 is 13. Use the square root property, and we get that L, our slant height, is the square root of 13. Now find your surface area. Our formula is 1/2 PL plus B. Our perimeter here would be 4 plus 4 plus 4 plus 4, and our slant height is the square root of 13. The area of the base is the area of that square, so length times width, 4 times 4. 4 plus 4 plus 4 plus 4 is 16, and 4 times 4 is 16. 2 goes into 16 8 times, so we have 8 square root of 13 plus 16. And type this into your calculator just as it is, and that gives us approximately 44.84. I need to think about my units here. So if I think about the area of the base, I have feet times feet, or square feet. Also, if I think about the P times the L, my perimeter, I'm adding feet together, so that still gives me feet. And the slant height is measured in feet as well, so feet times feet is still square feet. And so our surface area here is approximately 44.84 square feet. Look at example 6. The Great Pyramid is a right square pyramid with a height of 148 meters and a square base with a perimeter of 940 meters. The altitude of each triangular face is 189 meters. That means that the slant height is 189 meters. The basic shape of the Transamerica building in San Francisco is also a right square pyramid. It has a height of 260 meters, a square base with a perimeter of 140 meters, and the altitude of each triangular face is 261 meters. So again, our slant height for the Transamerica building is 261 meters. How do the lateral surface areas of the two surface structures compare? So notice we're focusing on lateral surface area. So these are the triangles, the faces around the top of the pyramid. This is not including the base of the pyramid. So our Great Pyramid, we're given that the perimeter is 940 meters. Well, the base is a square, so all four sides have the same length. Divide 940 by 4, and that tells us that one side has a length of 235 or 235 meters. Now, our lateral surface area, again, is the triangles around the top of the pyramid. There are 4 of them if you think about the shape of a pyramid. And the formula for the area of a triangle is 1/2 base times height. Our base here is one of the sides of the square, so that would be 235. And the height is that slant height, 189. 2 goes into 4 2 times, and then 2 times 235 times 189 is 88,830, and notice units are square meters. Now let's think about the Transamerica building. It has a base that's a square, and the perimeter of that square is 140. Since all 4 sides are the same, one side would be 140 divided by 4, or 35. Then thinking about the lateral surface area, again we have 4 triangles, and the area of a triangle is 1/2 base times height. The base is one side of that square, so 35, and the height is the altitude of the triangular face, or in other words, what we call the slant height, 261 meters. 2 goes into 4 2 times, and 2 times 35 times 261 is 18,270, and our units again are square meters. So notice that the lateral surface area of both structures is measured in the same unit. So my last step is to compare, and I can compare by dividing the lateral surface area of the Great Pyramid by the lateral surface area of the Transamerica building. Type this into your calculator and we get about 4.86. So that tells us that the lateral surface area of the Great Pyramid is about 4.86 times the lateral surface area of the Transamerica building. Now, let's think about the surface area of a cone. Specifically, we want to talk about a right circular cone. Our formula for our surface area is pi r squared plus pi r L. R is the radius of the circle, that's the base, and L is our slant height again. So here we're asked to find the surface area of our cone. Our formula for our surface area is pi r squared plus pi r L. Fill in for R and for L. So our radius here is 3 or 3 centimeters, and L, our slant height, goes down the side of that cone, so that's that 5 centimeters. 3 squared is 9, so we'd have 9 pi square centimeters, plus 3 times 5 is 15, so 15 pi square centimeters. These are like terms, so add them together, it gives us 24 pi square centimeters. And type this into your calculator if directed by Math Labs, and we get approximately 75.398 square centimeters. Look at part B. Again, we're asked to find the surface area of our cone. Now notice this time we have the height of the cone rather than the slant height of the cone. So first, I need to find my slant height. I can do that by thinking about the Pythagorean theorem. A is 2, B is 6, and L is the hypotenuse, or C. 2 squared is 4, 6 squared is 36. Add those together gives us 40. Use the square root property, and we get that the slant height is the square root of 40. Now we're ready to find our surface area, and we have our formula that we can plug into. Our radius here is 2 centimeters, and L, the slant height, is the square root of 40, and our units here are centimeters. 2 squared is 4, so we'd have 4 pi square centimeters, plus, and then I'd have 2 pi square root of 40 square centimeters. To type this into your calculator, you would type in 4 pi plus 2 pi times square root of 40, and we get approximately 52.3 square centimeters. Last, we look at our surface area of a sphere, and the surface area of a sphere is 4 pi r squared. So let's find our surface area of the sphere in example 8. Our formula is 4 pi r squared. Our radius here is 6 inches. 6 inches squared would be 36 square inches. 36 times 4 is 144, so we'd have 144 pi square inches. And if Math Labs directs you, type this into your calculator, and you get approximately 452.389 square inches. Look at example 9. Susie's kindergarten class is painting Christmas ornaments. The ornaments are spheres with a diameter of 2 inches. She has 20 children in her class. How much paint will she need? Well, first, our formulas have radius in them rather than the diameter. So our diameter is 2 times our radius. Here the diameter is 2 inches. Divide both sides by 2, and that tells me that the radius is 1 inch. Then I find the surface area of one Christmas ornament. So 4 pi r squared, plug in your radius is 1 inch. That gives us 4 pi square inches. Now since Susie has 20 children in her class, I'm going to multiply the surface area times 20. So 20 times 4 pi square inches is 80 pi square inches, or approximately 251.33 square inches.